it with those who cannot make it during the session lah. Okay. Jadi boleh cuba share your screen ke?
Sekejap ya.
Yes.
Boleh nampak ke? This one.
Okay, boleh. Okay, so good morning, everyone. We
Morning.
would like to thank you for attending this event. The seminar is about the organization and buildings conjunction with UNIMAS Water Center event. We have invited our speaker, Mr. Razali and Bakar, who's also the president of Malaysian Association of Registered Energy Managers, REEM. And so without further ado, I think we can invite speaker to start the seminar. I hope it will be an interactive session. If there are any questions, we can actually start raising our hands, and myself as a moderator, I will try to moderate the session and make it as interactive as possible. So without further ado, Mr. Razali, the floor is yours.
Okay. Thank you, Associate Professor Dr. Danial. Thanks for inviting me on this what we call water optimizations in the building under UNIMAS. Okay, this morning basically I akan gunakan dua language lah in terms of the what we call this shared informations on these water optimizations in the buildings. Okay, total I think about 20 something slides, but we're just as mentioned by Dr. Danial, basically it's supposed to be an interactive. Any question arises, I try to answer. If not, I will later put on email as an official answers. Okay. Okay. Hi everybody. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Okay, going through this water optimizations, basically I would like to link to SDG, Sustainable Development Goals under United Nations, whereby I put on numbers of search I'm looking at is linked to this SDG number 6, clean water and sanitations. But I also put in terms of this the other two, for the sustainability cities and communities, and also for the number 12 is responsible consumptions and productions. Reason I'm putting this other two is basically once we have a better what we call this clean water supply, optimized water usage, it can be linked to this what we call the sustainable cities, and also each of every person here basically is responsible for the consumptions of this water. Okay. Why we need to optimize water? Basically is to minimize water consumptions. We can also reduce the strain on local water resources. Remember these days a lot of basically I can say start-stop water. Morning, no water. afternoon a little bit, malam baru kita ada water, and it always now it become a regular already. And then this part of it is basically either in terms of what we call this water leaking, or we are in the dry seasons. Okay, in fact in Selangor, 3 days there will be what we call water shortage from from the 5th to the 7th of June. This is basically I can say a normal condition that we have to face at this moment. Okay, and the other one is basically is preserve natural ecosystems. Once we can regulate, or we can control our usage, then what we call the storage of the water, actually we can control in a proper way. And the other one is basically to ensure availability of water for the future generations. The more that actually we conserve, of course there will be evaporation, whatever that thing, but inside what we call this storage area or reservoir, you know, the more that actually people concern out of it, the more that actually we can prolong the reserve of the water itself. Okay, in terms of commercial buildings, I put five category basically under the commercials. Number one is in the office buildings. The second one is hospitality. The third one is institutional, and then the other two is sports complexes and the retails. Okay, I put numbers of involved in audit the buildings, but more towards this electrical energy. But we really that actually I can say we neglect in terms of putting this what we call this water as part of the important resources. But when it comes to the reality that actually we need to analyze in terms of getting how much actually we use. In fact, each of individual of us going through what we call monthly receive the bill. We sometimes actually wonder why that actually so much that actually we have to pay the bill. You know, where actually this water from the supply, and then what actually the usage inside our house or inside the buildings. Okay. I would like to link in terms of what we call what is the current law that actually available to promote water conservations in our country. Okay. In my research, that actually I found out on that basically still on the draft that actually going for this water conservation, because have a look on this the snapshot of this news that actually SPAN drafted law to make labeling and the use of water efficient devices as a mandatory. Then basically stated almost like 80% by at the year of February 22. I can click on this. Can you see this one? Can you see the news? Can I see the news?
Yeah, I think you need to share another content.
Switch. Okay, never mind. Okay, I just read some things that basically what we call to share the information later for this PowerPoint presentation or the PDF. I will share, and then you can have this link much more clear. Basically, it stated here that basically for Malaysia, higher than what we call the United Nations or Singapore usage by almost like 200 to 280 liters, 200 liters per person. You know, sorry, per household. Compared to Singapore, this is about 143, and then they are targeted 130 liters by 2030.
Sorry, is that considered a lot or
A lot, yeah.
how?
Actually, we are using more than the what we call our neighbors in terms of water usage. Okay. I also put this link of this what we call later I can reverse back on this thing since okay, there's a link about this each of individuals on newspapers related to what we call the conservations of water itself.
Encik Razali, can I ask a
Yeah,
question? My name is Rosmina from Water Center. I just wonder what happens at the disparity between the usage in Malaysia and in Singapore. The gap is quite big.
yeah,
And we have been advocating that, you know, each of us must use or must conserve water. We understand that the tariff here is much lower than it is in Singapore.
correct.
Any other reason why the usage in Malaysia is higher than Singapore? Is it because of our, I don't know, is it NRW, is it the tariff? If you could enlighten us.
Yeah, when I look at this one, according to this what we call span in 2019, usage water demand per capita for Malaysia is about 230 liters, highest than WHO, which is mentions about 165 liters per day, per person per day. So what I can say here that actually, okay, in fact, I'm also looking where actually this data, I mean more details about the graph, where actually, you know, individual, how they put that kind of informations in details about individual 230 liters per person per day. I mean, I'm also wonder that actually in our house also that actually if you takes about what we call take a shower plus you are using your toilets, everything. I don't think so that actually we are having about almost like what we call 230 liters per day. You know, then but this data is came from span itself lah. Might be that I can say that something what I can say in terms of okay, could be also count in terms of leakage from the supply itself. You see, so much produce and the actual details about the usage itself, and the other ones that I can see also in terms of what we call the behavior or the way that actually we are currently practicing. You can say that some things that some people actually doing this washing of their car continuously. Okay, so could be that one also. And then the other one also, if you see that some things, I mean, as I put a link about the Muslim itself lah. Okay, if you go to this what we call this surah or individual house also, how they took the ablutions or the wudu itself.
Yeah, I was trying to relate with our religious activity, but in the wudu, most of the time we
Yeah, you
don't
can,
really try to conserve the amount of water that we use. Perhaps
correct,
having
correct.
the automatic sensors. Sometimes if we use the automatic sensor, we tend to complain that it's a bit
It
hard to
yeah,
actually
come
do
out just a
ablution.
little bit, you know, and that.
Yeah.
But actually, in terms of the actual suggestion, which is, you know, in one bottle of water also we can complete our wudu.
Yeah, that is true. Yeah.
Yeah, and then you can see some places all the floor also is wet because of people put so many things, and then you know by I mean one step to another step of wudu also, water just go through. I mean going through that kinds of wastage. That's what I can see, you know, in terms of when you take bath. I don't think so that actually there's so much water that actually been looking, in part of it. But I can say is part of it is a behavior lah, behavior. And the other one also, what I can see also, that actually the devices. Later I will show you in terms of how much actually the difference each of individual house that we have the what we call this fixture installed inside our toilet. Is it follow to the latest one? Okay. Shall I continue?
Yes, please.
Yes, please. Yeah.
Okay. After I'm going through these introductions of this water usage and what on the span sharing about the informations, I would like to go in terms of this water management. I put a link where the source that I'm taking the information. Basically, for the water conservation plan, we go through for this 3-step for preparing water conservation plan, develop the water system profile, and then prepare for the demand forecast. This basically it will get involved in year-to-year basis from what actually the facility management going through in terms of putting this 3-step for this water conservation plan. Okay, for the second one, the develop a water system profile. This is whereby that actually, in terms of measurement plan, will take place. Supposed to have a good monitoring system that we can understand the profile of usage each of individual either floor or the whole buildings that we can see the trending out of this water usage of these commercial buildings. Okay, I put also this one. Objective of this water management is basically as an access to track and conserve water in the buildings. The other one is basically on putting and demonstrate water reuse opportunity. And the other one is using a code and standard to design or specific water management system. One is ISO 46001 2019. Also utilized in terms of SPAN technical guide, and also for the GBI assessment and tools. These three that actually we can use as part of our tools in terms of putting this water management in the buildings. Okay. Copy out of it later. I will email to Dr. Daniel if you want to look in terms of this individual of it. But most inside this presentation is a snapshot of that particular information. Okay. So overall water management strategy is basically to match the quantity of demands and potential to reuse again. This part of it is basically is integrated approach to deploy water use reduction along with a various reuse scheme. I put also the link here for the SPAN technical guide that actually putting on individual what we call usage when we put into the design of individuals requirement inside the buildings. Okay, just want to share the snapshots of this ISO 46001 2019 water efficiency management that basically will what we call will put multiple benefits for the organizations lah. And then it basically has effective implementations of water efficiency, but not only result in substantial saving energy, but also in water, but also on energy. Inside the buildings, water energy is a very close relationship, especially for the ACMB systems lah. Whereby the transportations of chill water is related to the energy from pump itself. So each of the single flow of this chill water need to move by the pump, and basically that's part of it, what we call related one another, and we can refer to MS 1525 2019. If I'm not mistaken, under the chapter 8, that actually has a recommended what we call optimum power for each of individual, either on the chill water or the condenser water. Okay, the other one also basically the impact of water discharge over the long distance lah. This involves also on the cold water supply to the buildings. The other one is basically the adoptions and proper implementations of water efficiency management system, which is intended to improve water efficiency. Then along with it, basically first is to identify water as resources and part of organization and budgetary plan. Also, it will assist organization for better manage water usage, optimize water demand, recognizing the impact that can occur if we change water use. The other one also accountability, and also the provide process for regular review that we can actually improve and adopt opportunity for this water efficiency. The other one is basically saving in operation and reduce water consumption through sustainable and efficient design. Of course, use water conservation device and proper monitoring. Okay, I would like this one. This is a snapshot also in terms of the planning process. We have 3 categories basically: the planning inputs, the water use, and also the planning for the outputs. Planning inputs is basically come from the source of water, relevant environmental factors, past and present water use for activities and functions, and also relevant variable affecting significant water use. Okay, and then in terms of water efficiency performance, then we need to also have a water use review, analyze where the water use, identify activities and functions, and also opportunity. The planning output is basically for our business activity indicators lah. Basically, we can relate net flow area compared to actual meter cube utilized in the building itself. And then we can develop also the water efficiency indicators by putting this water performance indicator. And also the other 3 is objective, target, and action plans. So this actually all that we can put under the PDCA lah, plan. Go through these ISO terms. Any question on that particular so far before I continue on the other one?
Razali, so
Yeah.
basically, this kind of ISO interesting. This is actually first time that I know there is such an ISO in terms of related to water. But as we know, even for ISO for like energy management itself, people tend to not seeing it as something required to be done because we don't have any law enforcement even. So
Correct.
how about this water management? Do we have any kind of enforcement or law that require us to actually do this kind of management, or we simply have nothing?
Currently, as I put on my what we call have a look on this one. Malaysia is basically draft law to promote water conservation. So at this moment, I didn't see any what we call enforcement directly to the users to go through this what we call this water management. But in terms of energy management, for the latest EECA, Energy Efficiency Conservation Act, energy management will be a mandatory. a mandatory implementation by the what we call the user that actually under the law. So I believe that actually later this will be part of what we call a way or the strategy that everybody that actually will get involved. Okay, and then even UNIMAS ISO 50001 also at the early stage is basically is more towards option to apply. Okay, but I suggest that basically each of individual buildings use this one as part of what we call the business process without going through any certification, but follow whatever inside the ISO suggestions in terms of this 46001. And this will lead basically towards a very good what we call business directions. Later also, I believe on this what we call the sustainable report or process, it can be used in terms of getting a proper informations to put inside the yearly report, and also have a very good impact for the business, especially for all these commercial building, to show that they are part of the sustainable communities. That's why I also put for the SDG under SDG number 11 for sustainable cities. I'm not sure later if someone in terms of the what we call this stakeholder voice up, and then the government take this one as part of the initiative. I believe one day it will be one of the what we call mandatory exercise to each of the individual. Doctor? Am I clear, Doctor? That one?
Yeah. Okay. I think one of the reason is because of that low implementation, or perhaps the tariff is very low. So somehow I think we eventually we might need to relate it with money, because then only most of the
True.
club managers
Correct.
feel
Correct.
that it's important.
Yeah.
Okay.
All right. So I just want to share our neighbor. Not say that I'm looking to the nearest one basically for the Singapore. They have basically the regulations that actually are mandatory for large water users with net consumptions at least 60,000 meter cube to send report, and also for them to put mandatory water efficient management practice. Okay, this is in Singapore. They also need to have what we call water efficiency manager, same like this registered electrical energy manager, and then submit their annual water efficiency management plan, WEMP, for at least 3 consecutive years. So tracking everything on their side actually is already ahead of us, basically. Okay. They also put what we call in these informations. They have a template guide. Okay, water efficiency management template guide, and also for the how they actually they need to put reportings on this particular information. But most that I can see numbers of paper or something, that actually water balance is the most important in terms of what we call try to understand from the source of the water, and also the usage or utilizations of the water in the building or the other places. Okay. They started since January 2015. So now we are already what we call 2024. So we left around 9 years behind them. And then we know that actually, we in numbers of places, especially like Malacca, even though Selangor also, the supply of this water is part of the crucial sources for each of individual state.
So it's kind of funny. I'm not sure what's the tariff for Singapore, but it's kind of funny because most of the water sources is actually from our side, right?
Betul. From Johor itself, and then
So,
I mean, it doesn't make sense with that kind of what we call the tariff, but it's already been signed.
yeah. And then so if you think that the tariff is quite low, I mean in terms of pricing is quite low, but then they still try to manage their water consumption. So I think it cannot be a reason for us to actually
Yeah, to
because our tariff
neglect.
is
Yeah,
low, then
yeah. I think I believe that actually ministry actually is going towards this direction since energy is already put in place. So I believe water also will come later. This part actually totally I agree. We cannot neglect in terms of putting these enforcements. Otherwise, we still thinking that water is the most cheap resources. Okay, that actually we can put, one side of our eyes and still put into the waste on whatever, the situations. Okay. All right. Just want to have some what we call I take also the snapshots, but what I want to emphasize here is basically in terms of they put a links of the water supply which is not from the actual resources, and also that actually the water output. Here, the first one is water that is lost through evaporations or drift. Example, in terms of the cooling tower. The others that actually is not in what we call, but the D also in terms of effluent from wastewater treatment if the building has that kind of facilities. But I want to emphasize here is basically whatever that we want to start to do something in terms of water management, get to know in terms of the water balance. The total water input, if we say, is also equal to water output. But in terms of during the tracking, that we will find out that basically there will be a loss. A loss, it could be from the leaks. The loss, it could be from something that actually not been tapped. And also the loss also, it could be from the one that actually not utilized directly by the normal consumer, but by the facilities itself. Tracking and conserving facilities water use, that actually the one that we are aiming for in terms of getting to understand what actually in terms of the water input and what actually the total water output. I always put this phrase, in order to control that we have to measure. Okay, this is one of the phrases that I always use when talk to the customers. In order to understand some things, we need to have a figure. Otherwise, we just actually something continuously don't have what we call a solid basis of arguments or solid basis of analysis to move to the other steps. Okay, this is actually I put a screenshot from GBI water efficient calculator. Okay, it also a free tools that a user can use. Come to, okay, before that, basically water efficiency under GBI, there's a 10 points. It come to the assessment through water harvesting and recycling, and also the other one is on the increased efficiency. Okay, I put a link also where actually that you each of us can download, and the manual that we can use. We can start to utilize these kind of tools that will assist us to understand on our buildings where actually is our benchmark or where actually we stand in terms of water efficiency. Okay, so back to this one. Just want to have something that I mentioned earlier about the water balance equations. You can see here on the water demands that from all that individual utilize what we call point. They have also the other one in terms of this is the normal in terms of water closet, laundry, kitchen, cleaning, wash machines, shower. And the other one is basically the biggest one I can say is air conditioning, makeup, water tank. Okay, the others building, if hotel, then you have a pool, then you have a landscape, you know. They have also the combinations of if the building use rainwater as part of the what we call source of water for that particular buildings. This one also, there's a one what we call assist tools. Sorry, I didn't put inside here that basically you can get what we call a forecast in terms of how much that actually rainwater that we can harvest with the related to the area in terms of what we call the rainfall statistics, and also the design in terms of the area storage for the rainwater itself. Later, I will try to get that information and share towards and update this the PowerPoint presentations here. You also have a wastewater recycle, and also here, okay, this is something that actually so far through the audit, I haven't seen any single what we call building get this part of air conditioning condensate water to basically collect these sources and use to the other side. But one factory that use this kind of what we call practice, one of the factory in Malacca, okay, electronic factory, yes, they link the 12 of these what we call chillers plant to collect all this condensate water through their factory to use to the other side of what we call utilizations of the water itself. Any question on this one?
Yeah, I think we have one question from one of the listener, from Mr. Kamaruzaman. How
Okay.
about hospital equipment with hemodialysis? And can this kind of practice be used? Hemodialysis.
Oh, I see. Okay, I don't actually familiar with this dialysis practice, but I can get back the answers on that particular that ones. I understand the process itself, lah.
Because we need to know the process flow as well, right? I mean,
Yes,
one of
yes,
the
yes.
Mm.
Mm. Once we get the process flow, then we can understand where actually, you know, the portions of the actuals water utilizations, that one. Okay.
Okay, thank you, Encik Kamaruzaman, for that question. Yeah, I think the complexity of the processes
Yeah.
sometimes, and then regards to hospitals, they are kind of quite strict, right, in terms of how some contents that's being disposed is being used.
Yeah,
or
normally
not.
in the hospital, especially for the wastage, that one, they have basically a dedicated what we call a center of collections that actually need if water basically need to be treated with certain requirements from DOE, okay, but especially for this Hospital one, normally each of that thing need to be disposed. Basically, that's what I understand lah. This kind of, especially when involved in terms of the health considerations, other than the chemical considerations, that one. But I will get what we call the detailed answer from the facility management guy, and we'll share that one later. Okay. Okay, this back to this what we call the point inside the I suggest to use the tools that actually we can analyze our water efficiency using this GBI water efficiency points. I also put what we call the calculator itself, and also the manual that we can go through. Example
These
here.
these are free, right?
Yes, this is all free tools. This is all free tools.
Some people don't realize that it's free, and then including myself lah.
Except for
Okay.
the copy of ISO lah. Copy ISO normally is you need to get download, and then sorry, you need to pay before download the actual one for the ISO. For the ISO that 46,001, that actually I think about 100 somethings USD if I'm not mistaken, that one. Okay, but this under GBI is free. The tools for the assessment is free. The calculator also free. So you can utilize that one. Even just now that I share in terms of the Singapore one also, you can compare that one. That basically more towards reporting. But for what we call this water calculator by this GBI is I can see much more details. They put each of individual requirements in terms of the water efficient fitting, the usage of individual, that you can see at the end. There will be a report in terms of the energy balance itself. Okay. Okay, just want to share what we call just now mentions about the tariff. This one of these tariff under Selangor for the what we call for the building. This is the shopping complex, the wholesale shopping complex in KL, whereby each of the meter cube rate at RM2.62 for the first 35 meter cube, and then the rest out of it is RM2.88 per meter cube. Okay, compared to the household, of course, it's a multiple percentage increase. Here you can see these buildings utilize per month is about 11,404 meter cube. The actual amount of money paid is about 32,000 ringgit. This is the examples of the 2023 water usage. Each of individual.
Sorry, Razali.
Yeah.
Sorry to interrupt. This shopping complex is how big in terms of the how because I cannot imagine.
Okay, the
big
net floor area is 47,152. It has what we call 7 floor of business floor, and then they have another 5 or 6 floor for the parking.
That's quite big, 7 floors. Okay.
Yeah. Total floor is 17 floor. But the actual commercial is basically 7 floor. Okay, located at Kenanga there. Jalan Kenanga in Kuala Lumpur. Okay. So monthly is around 11,000 meter cube. 11,000. Okay. And then this is a private hospital. Private hospital in Johor. You can see almost like 1/3. But the what we call net floor area is almost like 2/3 or half of this shopping complex. One is 47,000, one is 28,000 meters squared. Okay, you
So
can
we
see.
can say that the commercial complex building is not using their water properly, right? I mean, not managing. Can we say that just by comparing the figures?
Okay, okay. What I can say, I didn't put that one in terms of managing or not managing, because I put the first emphasis to get to understand this one. What I can say, I put another what we call this one. Just want to show you in terms of the cooling tower water usage. Okay, the cooling tower water usage based on what we call evaporation rate, like 0.1%, 0.2%. You can see that actually the bigger the chillers actually is also will come to their cooling towers capacity or tons. So each of this one, imagine with 1,000 tons of cooling tower, that actually monthly evaporation is 4,968 meter cube. This shopping complex also running 1,000, I think 1,000 or 1,200 RT. So meaning that almost like half of their water usage actually is come from the chiller plant because of the water evaporations.
And can we actually control the evaporation or how? Because
I mean, the more that actually, I can say the more that actually the heat being absorbed from the building, the more that actually, you know, evaporation rate or the utilizations of this cooling tower that will reflect the water usage on the building itself. If we can control the load of the chillers, then the water what we call heat rejection also become lower. Then the water usage also become lower. That actually what we call the relationship between the water usage from the cooling tower itself compared to the what we call the cooling capacity of the building. This is one way. And not to count also, if you visit the what we call the chiller plant, cooling tower, floating valve faulty, water overflow, splash, you know, you can see the floor is all, most of the time is wet and algae. Okay, the infill also damaged, where also is splashed out, that one. So the actual operations in terms of calculations of this cooling tower usage plus the leakage plus the wastage, they actually come more in terms of each of individual chiller operating unit. This is what I can see, that one of the reason for the what we call the buildings that actually need to control their ACMV, which is in terms of significant energy use about 60% from overall. So the more that actually the concerns about this air conditioning system, it also will relate in terms of their water. Okay. So I just want to make what we call have a feel about the comparison between the shopping complex and also for the private hospital. I'm not sure that I haven't actually asked the data for the UNIMAS, how much actually the value in terms of RM and also what actually the capacity usage per month for the UNIMAS, doctor.
yeah, I think we should have a look on that as well, because we know that the consumption of energy, we have been focusing that so far, but I think it's quite a good idea, right? Terusmina, I think because Terusmina is the director of the UNIMAS Water Center, perhaps we can request such of information from them. Perhaps,
Yeah, you know
just to
that
get it started.
the other one I would like to actually not say suggest like actually to get this chiller plant for the cooling tower to be metered, so that actually we can get this between the design as per specified of this consulting engineer and the actual one. You see, so that from there also that we can have a benchmark in terms of water evaporations, whether actually is follow the design or the unit actually the cooling tower itself is consume more water than supposed to be. Okay, that part of that one. The other one also, there's a one of my client before. I'm not sure in Sarawak that do you pay also for the sewerage under the IWK?
Not sure
Not
about that. I
yet.
think
No, we don't have that yet.
I see. Okay,
Uh,
in here that basically you have to pay for the IWK. Each of bill come for this your water bill, it will commemorate the actual IWK bill also. Okay, so it will especially for the commercial, it will relate to the actual meter cube water usage. So one of my clients hotel in Kuala Lumpur, what they did, they metered the cooling tower water usage. Okay, the cooling tower water usage, the actual that one, they analyze about the evaporation, the actual water coming to that one, and then the actual water utilized by the cooling tower. The difference actually is evaporation. Evaporations, water didn't go through the sewerage. So they claim back that actually that one to the IWK. So that is also what we call one way of try to understand the water usage in the buildings. So
sorry,
in
Razali,
yeah.
the metering itself, is it expensive? It's not expensive, right?
No. Water for the fixed one is not expensive. The water one is not expensive. It's not what we call the flow meter, like what we call this
Yeah. They don't have
ultrasonic. That is expensive. Yeah.
That is expensive, right? So, but we don't need
Yeah.
that kind of
No.
of
It's just a normal. You see the normal what we call the water meter that actually installed in our house, and also for the building itself. I think we can get a few thousand, or sometime in much more cheaper. You can get what we call currently in open market that you can install. So we can monitor that one properly. So as I said lah, that on my previous slide, in order that actually we want to control, we need to have the numbers. Okay. So you can see these two. The bigger, I mean, what I can say, the bigger the area, the bigger actually what we call the water usage in the building itself. Okay. Okay. Any questions so far? Because I'm come to the others what we call 3 or 4 slide before we end up our sessions lah. I saw one question related the influent standard, that one. I will get back this one from the what we call the actual people involved in terms of DOE requirements.
Hello.
Hello.
Yeah.
Okay, Gopal is actually my PhD student. He's an engineer in Shell, right?
I see. Okay.
Yeah. Thank you for my question. So the question is regarding the discharge, actually, the discharge specification, because most of the time that we are also asking the government regarding the discharge quality, and then so what is the standard specification in terms of the effluent water spec reference, as we know that there is a DOE standard, which is standard B and standard A. If there is
Okay.
any other standard that we can follow, because we also do the innovations, which is we are using the UF and RO waters from the wastewater, in
Okay.
the plants to treatment the water to get to supply the shortage, which is for the long term because of the water supply shortage. So we want to increase the water consumption as well. But also that we just to ensure that we are in the
Follow the
water
requirement.
specific, follow the regulation. Yeah.
Yes.
Thank you.
Okay. I will get back to you this one from the industry associate. Will communicate directly with Dr. Daniel in terms of this what we call this question. Okay.
Sure.
Okay, Mr. Groper.
All right, thank you. Because the answer that we always getting is that based on the available techniques. Yeah.
Oh, okay. The answer is based on best available
The
techniques.
availability techniques. Yeah.
I
So
see.
what we do is that we do the pilots and then we compare with the effluent water spec reference standard B and standard A DOE SF
Okay.
now lah.
Okay. All right. Okay. Thanks for the question. I will get back to you that one. Okay. Okay. I continue on my what we call the next slide. This basically just to share what we call simple ways to save water in this commercial building. I took the resources from this link. Sorry, this time I forgot to put what we call the QR code that you can also have a look that one together. But later I will share this one. It's about what we call I choose 3 first for the low flow plumbing fixtures, and also for the rainwater harvestings, and also for the cooling tower water recovery. That's on the number 8. I try to emphasize in terms of how much actually water been used for each of individual what we call chiller capacity. Okay. Have a look in terms of this fixture water and usage rate. Basically, I would like each of us have a look in terms of our own what we call fixture water inside our house or inside our facilities. Have a look in terms of this one taken from the USA EPA paper, stated that actually fixed water usage reduction since 1992. They have basically what we call pre-1992, first generation, second generation, third generation, high efficiency, whereby you can see the dual flush that currently numbers of building or numbers of the new house change to this one. Okay, it's from 3.5 gallon per flush compared to now is only like 1.6 or 0.8 gallon per flush. That basically reduction is about 63%. This to me is a lot. And you can see that basically this what we call this under urinal, under showers, this one, each of individual, that actually you can see 63% for 93% of these reductions. They actually will give a significant impact in terms of what we call the target to each of individual of household to have a better what we call water consumptions. Any one of us that actually can share that actually in terms of their house is already full replaced with this what we call dual flush water fixture.
I don't think. I think most of our house they don't have that. No, but my house has the 2 type. But I don't really when I flush I don't really watch which one I'm pressing.
select which one. So
Yeah, I just sometimes I just press both, So that, I think that's the awareness. I'm not sure about the rest of the members in the session right now, but my personally, yeah, we know that we are promoting, let's reduce our water consumption and whatnot. But when I think about it again, I don't think I actually, select or choose which one to press when we are using the toilet.
Yeah.
We
Shame
are
on me
aware,
as well.
Dr. Daniel. We are aware of it. That's the reason why there are two.
Yeah. Why there are two selection, the dual flush.
Two
One is the
selection.
small
Yeah,
one,
but
is
I
the
think
big
I
one.
think
Yeah.
when I just press both. I think.
So small business, select the small one. Big business, select the big one for the flushing one basically. I think interesting also if UNIMAS can make what we call a study case on this one with total numbers of fixture, then compare to this kind of information, how much actually we can save in terms of the water usage. UNIMAS fixture is already equipped with the dual flush.
Yeah.
Yes.
But again, sometimes we don't, because the size is the same. You're not sure which one is small, which one is big. You just press because there are two buttons, but both, you don't know unless.
Yeah.
Sometimes we just press both as well.
I see. Okay.
I must tell you, in Razali, this building has been occupied but 18 years ago, so we already have that. So it has been there for the past 18 years.
I see. So I mean, as a quick check also, like the first stage of what we call audit, we can do what we call the desktop audit towards the what we call the commissioning information. We can check that one. At least we can put what we call a benchmark or the baseline in terms of this fixture water that actually available. I mean, not only on UNIMAS but also in terms of the building itself lah. And especially in our house, you can see the difference lah. I can see the difference. The previous one that actually that examples of my house, I can see that actually the bill can 30 to 40 ringgit is a lot of different to me also that way by having the old fixture and the new fixture, that one. But practicing and awareness lah, as Dr. Daniel mentions, after we do the business also, we have to think the next step, that actually need to be practiced also. All right. Hope that actually we can look this one. To me, this is the bottom line. The bottom line, because we do business most of the time on these pictures lah, basically. Okay. The utility is basically on the other side of the highest usage. Okay. I just want to share about this one also. A simple what we call a diagram that I took from the internet on how that actually the rainwater harvesting. In here, we can see that a lot of R&R, they put a tank that actually rainwater is basically collected for the usage of this, what we call either the normally is using for this flush. If they have a very good water filtration system, then it can use for this drinking water or showers or the others utilize of this water that actually been treated. You see the other one also that actually something for the normal wash, they treated to be reused in terms of this for the toilet itself. But I'm not sure that actually this kind of practice as stated inside the GBI also. That so far I don't have any experience of really what we call putting this direct analysis or direct audit in terms of this setup or these installations. Any part of this UNIMAS that actually had?
We can see a lot of proposals of rainwater harvesting, especially those new buildings and those rural areas. Most of the time, they are doing rainwater because they don't have any tap water. And I've seen few of the rural mosques, for example, they also use rainwater for the ablution.
Okay.
But I don't think we really monitor it properly.
Yeah, I can see one of the obstacle is about the storage. The storage and also what we call the captured volume itself compared to the actual usage lah. that need to put proper analysis on what actually percentage that we can harvest and what actually the actual demand in terms of this one, and actually it represent how many percent from the total of what we call the actual usage in one particular buildings or one house that way. UNIMAS that put any what a pilot project on this one?
No, right? The storm
Student
farm,
pavilion.
student pavilion, or they have GBI, yeah.
Yeah,
But do
I
they have
was.
energy harvest? Rainwater harvesting?
I believe the student pavilion has, if I'm not mistaken, that was a long time ago when they first built it, because I know they were aiming for some standard LED standard, if I'm not mistaken. But I'm not sure what it was because I wasn't involved with the design. But I know we have that, and Cik Razali, we are also looking at low carbon campus impact. So one of it is rainwater harvesting.
I see. Okay.
Yeah.
Okay, so that actually will represent some things about, I mean, reduce your cold water pumping also. That is one of the directions.
Yeah.
I see. Okay, good. Okay, so
But I think Dr. Daniel will be the one leading that project.
oh, I see. Okay.
Yeah.
I think good. I think
I can share with you some of the new buildings. Example, JKR new buildings all over Sarawak. They do request to have rainwater harvesting elements being embedded into their proposal plan. Because I am involved in some of the
project.
projects of JKR
I see. Okay.
specifically, and they do ask for rainwater harvesting models and that kind of things.
You can, I mean, back to what we call this look at this one under water harvesting and recycling. The under GBI, the rainwater harvesting got 2 points. Water recycling also got 2 points. So this part actually, if you put the, consider for the GBI later for the certification or others certification, that actually, as I understand, is one of the criteria they want to put for the later certifications lah. Okay, so the last one that actually I would like to highlight. Just now I already put on the explanation before. I put it here, what we call a calculation out of it for the 1000 BTU of evaporate of 0.12 gallons of water. So each of individual ton is about 1.8 gallons evaporation. So if I put this calculation, 1000 tons of cooling tower, total water evaporated is about 1800 gallons or 6.81 meter cube. So if the unit is running 24 hours, approximately is about 163.44 meter cube. So monthly evaporation is about 4,968 meter cube. So just now I show about this what we call a shopping complex that has what we call 4 chillers, but running only 1 chiller, I think about 1,200. So their bill of water is about 11,000 meter cube. You can see that actually water utilized for their cooling tower itself is already almost like half of their actual consumptions. I did mention here that normally when we do audit, we can see this one. Floating valve is faulty. Water is overflow from the basin. And also they can see, the water damage splash. You can see the wall of cooling tower plant that contains of algae growth. This is something that actually an indications about the wastage or something that actually we need to control. So this is something that actually, as I said, the bigger user of water inside the buildings, that we need to look into it. Okay, Not to mention also in terms of, even though the chill water, what we call the chill water is a closed operation. On the other side, this is the condenser water, but the chill water also has a backup water tank. They actually continuously been ready for the top up. Is something that actually leakage or something in terms of the flow itself. But that actually is not that critical compared to this cooling tower water usage. That basically end of my presentations. That we can go to this. If there's any other question, as I said, I will compile the question that actually something that actually I need to get further information or further clarification later. Dr. Daniel, over to you for the Q&A.
Okay, thank you very much, Mr. Razali. I think that's very interesting insight of water. We have been saying that water is very important to life and water is crucial. We need to do something about it. But yet, we ourselves, as I don't know about others, but for me, myself personally, sometimes I have to rethink again to actually try change the habits of doing some methods related to water, so that we try to really appreciate the existence of water in life. So thank you so much for that insight. I would like to open the floor for any kind of other questions. We did get some questions throughout the session just now. I believe it's an interactive session where some of the questions were raised. If there is any other questions from the floor? If there are none, I believe Dr. Rasmina, are you going to share the QR for the participation?
Sure, I can share the QR code. But while we do this, perhaps there are other questions. I see Engineer Muazzam from JBUB is here. Azam, if you have any questions, just ask. Don't shoot away, and share this QR code, ladies and gentlemen. This is only for UNIMAS staff and student. Razali, I have a question. Sorry, if you don't mind me asking.
Yeah.
I wonder, I know we have been talking about water optimization, but what about other electrical industries? Sorry, not electrical industries. Other industries which uses electricity secara dengan banyak lah. I was talking to Dr. Daniel the other day about a cold storage industry, if I'm not mistaken. So they use a lot of electricity. They consume a lot of electricity because they need to cool their produce. Yeah. Cold room. So what are the efficient measures for industries such as this cold storage?
Okay, the cold storage is back to the refrigerations. The refrigerations efficiency is basically the kW per ton also. Okay, it's also the kW per ton. If you want to put this what we call this cold storage efficiency, normally we will analyze this refrigeration system. Refrigeration system is basically we need to what we call to analyze between the kW input of the compressor and also the refrigeration output of the system itself. So from there, that basically we can establish the efficiency of the refrigeration system, the refrigeration systems lah. And as I can see that basically refrigeration system for the cold room, it has also individual, and also it has also the centralized system, meaning that individual is one-to-one condensing unit of the refrigeration system, whereby you can see like our split unit, the blower inside the room, the condenser is outside the house. That one same thing. The core room also has the same configuration, but if you put in terms of what we call the group of core room linked together with the common refrigeration piping, so it has multiple compressor to support like the VRV. You recall the VRV system that has one condensing unit that support numbers of blower for consumerate each of individual room required for the cooling. Do you have a VRV system in UNIMAS?
I'm not sure, the Daniel tell me because I'm a civil engineer.
Okay.
I need to check on that as well, because we really we know that we have to do it, but we have not yet started any kind of verification, any kind of taking information on that matter.
Okay. So I'm from the retail background also, that I'm handled the supermarket before. Okay,
I see.
so one of my handover project before, because I'm attached with the Lion Group and the group of what we call Parkson Supermarket. 6 years I've been in the company. So
Right.
so the Riverside also one of the what we call the commissioning that time. They have refrigerated showcase. They also have a individual core room. Okay, so as you mentioned, I just have one visit also. Just have one visit. Haven't finished my analysis about what we call the ammonia refrigeration system. Okay, for the process, and also
we still have ammonia refrigeration system in. I thought it's already, it's not like banned, but most of the time we don't want to use it because
I think they have a process requirements for making the margarine, whereby that actually minus 1.8 degrees C. I just complete visit with UTM to put a proposal in terms of audit this setup. Okay. So just now you see the factory is like a big core room. Each of individual, you know, the factory building is like core room, because the wall is equal to the core room wall, whereby actually is insulated with insulations a barrier, that one.
Okay, so there is room for optimization on usage rate.
Definitely. Each of you can normally, in terms of improvement or whatever that we want to see, what we call what I can say, you can have also this. Okay, I since I involved this one for the long time ago, but the company in Sweden, they make an innovations improvements in terms of what we call refrigeration analysis. Okay, that actually you put numbers of sensors for the liquid line, suction line, discharge line, everything. They put this kind of pressure, the sensor thermometer, that actually from the device, it can show you the COP, the compressor efficiency, the subcooling, each of single parameters for this refrigeration is being analyzed. Sorry, try to recall what we call the name. Later I will share with Dr. Danial in terms of the devices. Okay.
okay, sure.
Okay.
It's a very to me it's a comprehensive devices that can analyze this refrigeration system. Compared to if chillers, normally we will analyze the what we call the chill water side rather than the compressor itself, because it will involve what we call the pressure enthalpy chart on the refrigeration cycle analysis. So this company in Sweden, put this kind of analysis so you can see in terms of the refrigeration side whether the system is performed or not. Do you involve for analysis of this core room one?
No, I'm not involved yet. I mean,
We are
not
going to.
involved. We are going to. Dr.
Hopefully.
Daniel is going to.
Janganlah saya seorang.
Awak
Ini
lah.
members.
We've been waiting for him to return from his overseas trip.
So there's I just to share also that I involved last time as ESCO that actually install one of the federal alert what we call federal alert technology US1. They call LPA, liquid pressure amplification pump.
Right.
Okay,
Please
they
take
call
note of that, Dr. Daniel.
Okay.
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 Okay, Dr. Daniel, like actually the innovation under Federal Technology Alert US is recognized. Last time I'm with the others energy service company that bring this product. They call LPA. You can Google LPA, liquid pressure amplification pump.
Okay.
Okay, that actually is installed in the liquid line that increase I think up to 8 psi, but very minimum power input using the magnetic coupling motor. That it will improve what we call the refrigeration efficiency.
But this is for which system?
For the refrigeration for the cold room or for the supermarket one, even for the reciprocating chillers also that use that
So
one.
the chillers, yeah. Well, when we deal with companies, usually what they want to know is the cost.
Of course.
So if the cost is something that they can bear, or can we make use of any, low-hanging fruits that doesn't involve a lot of costing, if that's
Low hanging kalau low hanging fruit lah in terms of this cold room or what we call cold room related to refrigeration system. First, thermostat. Okay. First,
Okay.
thermostat. The actual temperature is calibrated accordingly or not? Okay. The second one, normally the door. Because of user open and close the door. Okay. Normally it will link to the what we call the inside evaporator fan. Once you open the door, evaporator fan must be off. Otherwise, it will bring the hot air coming to the cold room. That can also cause an ice for the coil itself. And then also
Calling back when you talk about the door just now, when I was in Charles de Gaulle's airport the other day, I noticed that they actually commonly close their doors. They only open 2 doors or 3 doors out of about 10 doors. And they place a sticker there, let's conserve our energy, blah, 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 something like that. So sometimes that kind of small, gesture or small action will actually lead to saving of cooling or heating the place itself.
True. If the door without you can see also kalau kata behavior, the user of the cold room itself, even though you put a blind they call plastic curtain, they will put the plastic to the door rather than actually supposed to serve as a barrier from the outside air to come into the cold room. That also will increase the energy.
So that plastic door
Yeah.
increases the energy.
Yeah, because the hot air will come inside the cold room. Kalau that plastic door, the curtain that one is been actually moved to the other side of the door, meaning that they hang or they gantung that one rather than actually supposed to be a barrier because they want to bring the goods in and out. So meaning that it's part of consider to them is an obstacle or halangan untuk diorang rather than the actual supposed to be a what we call a method of energy efficiency lah. this you can when you do the measurement, you can see the compressor cut in and cut off regularly because of this kind of behavior. Because it's always request for demand of the cooling.
It's interesting. I think we need to dig more and confirm more about that in the next project lah.
Tapi yang kalau yang Korum ni, even Tiong Nam also still use this ammonia. I understand Dr. Daniel concerns about ammonia supposed to be one of the list that actually, you know, in the list of DOE for banning to utilize. Even R12, R11 also, R22 also, you know, they have a time frame to remove that one in the market.
But that I assume that building or that organization is quite old, I suppose.
No. Just I think operated in 2019, open.
Oh, okay.
It's a very to me what we call
Tiong Nam yang kacang tu kan? Bukan tak?
Tiong Nam transportation.
Transportation lah.
Transportation and warehouse.
I see. Not the yang jual kacang tu bukan Tiong Nam kan?
Jual kacang
Macam
mana?
Tiong Nam juga nama dia. Kacang.
Oh, itu tahu yang
Tong Garden.
Tong Garden.
Okay.
Tiong Nam is transportation and warehouse.
Tong Nam kicap. Kicap dekat Sarawak.
Ini Tiong Nam, yeah. I think a lot of actually interesting to explore. Just mentions about the energy itself lah. That one.
Okay. Any other questions from the audience? If not,
I think there's one from Mr. Kamal Zaman. Then rainwater harvesting, do we need to check chemical tests because we store water inside the tank? From Mr. Kamal Zaman. We have to get back with that afterwards. Perhaps we will share some information.
Yeah. I will get back that one. Of course lah, kalau kata nak utilize for consumptions of drinking everything, we need to get the actual what we call the pH parameter accordingly tu lah. That one. But I will get the actual informations that one. Okay.
So we thank everyone for attending this seminar today. We will express our heartiest gratitude to Mr. Razali as well for sharing his experience in terms of water conservation and management in buildings other than energy management. We hope to see this kind of session in the future, perhaps for more seminar, perhaps from UNIMAS Water Center in the near future. Any closing remark, Dr. Rosmina? Dr. Rosmina is our director for UNIMAS Water Center.
Okay.
I think I think it should come from you, Dr. Daniel.
Okay. So thank you very much, everyone. We actually the seminar that we did today is actually a reminder as well to ourselves that importance of water. We keep on saying that water is the source of life and everything, but we don't really act toward what we are saying. Especially myself, I realized that again today. I hope I can actually try to change my habit, and we also hope that all of our participants here, and when we share our video afterwards, we hope that the habits of ourselves of making water as a very important resources will actually be implemented. We thank you so much, Mr. Razali, for this insight, and we hope to see you again in the near future. Perhaps we will have some collaboration in terms of any future projects together with UNIMAS Water Center as well.
All right, inshallah. Okay, thanks a lot for inviting me, so that actually can share my knowledge towards this water or energy. Anytime that actually I'm willing to share this kind of knowledge to the related one, basically. All right. Thanks a lot again.
Thank
So,
you,
Thank you very much.
Jason.
Thank you very much.
Appreciate your time. Thank you.
Thank you.